Okay, welcome back. This is Chapter 10. Chapter 10 is all about wide area networks. So up to now we've been talking about the local area networks. Now we're branching out into little bigger things. As always, we're going to start with the learning objective. So turn to page 325 and it talks about what is the need for wide area network technologies as they are different from the local area technologies. The three standard approaches, a common WAN technologies, what is a virtual circuit, and the location of where WAN fits on the TCP/IP stack. Okay, so let's just start from the big picture. A local area network versus a wide area network. So local area network, typically things like an Ethernet network, right? Is this just a matter of scale? I mean, is the difference between the two, is the definition of a wide area network just a bigger local area network? Is that the way it works? Nah. No, the technologies being used are radically different. If you remember the carrier sense multiple access, collision detection, all that whole thing, uses broadcast and has to listen before it talks and all the rest of those things. That's not very scalable when it comes to big, particularly long distances. For example, the collision detection would never work if things were like 1,000 miles apart. There's no way you could detect a collision. It's just not going to work. And furthermore, Ethernet relies on a lot of broadcast to make sure things are working and hello, how are you, and all that kind of stuff. Again, that's not really appropriate in a wide area network. We need to be sending packets that only belong on that link and no broadcast to everyone else. So before we get into the wide, let's talk about local again. So local area networks, typically in an office environment, the cable links are like about 100 meters or less. So right off the bat, you could have a star. You could have 100 meters going this direction, 100 meters going that direction. But the cable links themselves are about 100 meters. So like in a classroom, right? A classroom environment where you got 30 desks and they're all connected together on a local area network. Cool. That works great. Generally speaking, there is what's called low utilization of that entire network. In other words, very rarely would you have all 30 machines competing for 100% of the bandwidth inside that LAN. It normally just doesn't happen. Because people are clicking around and maybe people are doing something on a website or something, but it's certainly not saturating the cable for all 30 all at once. So it's relatively low saturation. It's very cheap to buy and install. I mean, you could just throw in a cable and no big deal. You could do the thing yourself. You could go buy you some bulk cable, put the ends on it, run it yourself, plug in your new machine. You're good to go. Now let's contrast that with wide area network. So wide area network is very expensive to buy, to operate, to install, and to maintain. I mean, there's some maintenance associated. Think of an underseas cable or a satellite link or microwave relay or all these things. Those are very expensive items, right? Millions and millions, and maybe even with a B, billions of dollars to lay undersea cables or launch satellites. I mean, that's expensive stuff. And then you have to have somebody who constantly maintains and tweaks it. This is certainly not something that you would do on your own. Okay. And they have very high utilization. In fact, from a money-making perspective, right, because these people are trying to make money for a living, they want to use 100% of the link at all times. That's kind of sort of their goal. It's just like airlines, right? Airlines want to have 100% of the seats filled when they fly a plane. Well, these guys want to have 100% of the utilization being used at all times. That's their goal. Now, distances cause problem with latency. So inside a local area network, there's practically no latency whatsoever. If I want to send a file from one machine to another machine on the same LAN, it's practically instantaneously. If I want to send it to a different continent, then we're going to have some problems. We're going to have half-second delay of the signal actually getting there and back, right? So those kind of things are kind of different. the book goes into this wild tangent about the road analogy, and the book is. Let me rag on the book for just a minute. They do a absolutely super job of explaining things that are simple to explain. Okay, so they have like 2 pages talking about the road system, and I'm going, oh, okay, I think we got it. Thank you. So I'll go through it, but rather rapidly. So there's 2 different kinds of roads. There's neighborhood roads, like a local area network, that are pretty cheap to put together. They're very low utilization. There's not cars going down my street non-stop, day and night. And so it's low utilization, relatively cheap put together. But when I get out on the highway, there's cars going all the time. And so it's high utilization and a heck of a lot more expensive and a heck of a lot more lanes to make things go faster. So that's a pretty decent analogy. So the conclusion is, what is the difference between all this? Well, using the road analogy, the wide area networks are much bigger distances. Okay, so they span a heck of a lot more than what a cable could possibly span inside a building. 100-meter cable length would be dang difficult to connect 2 buildings together if the longest length of cable you had was 100 meters. So these guys break that, so you could go as miles apart. And then they have the ability to kind of merge traffic together like a highway, where small individual roads feed into, and so everyone goes down the highway and then it fans back out at the other end. Okay, this chapter we're going to talk about 4 different types of these guys. The first one is point-to-point, and as the book says, it talks about these sort of like in chronological order about how they were kind of what came first and then followed by. It's a pretty good discussion. And then statistical multiplexing, and then the next one is optical technologies, and then the last one is these high-density multiplexing. So those are the 4 topics we're going to talk about on the choices for wide area networks. Okay, so cranking up on page 328, they finally start talking about the point-to-point guys. Okay, so in the beginning, point-to-point was, believe it or not, done with phones. So these were individual phone lines that connected these machines together. So I have a PDP-10 over here and an IBM 360 over here, and I want to connect these guys together. I would actually have my machine dial up and connect to these other machines, and they were point to point. If I wanted to talk to this machine over here, I dialed directly to it if I could. Okay. Now, this is not quite the same as what you might think of as the dial-up days from the internet at your house. This is on-demand dialing. So here's how it would work. I'd be sitting there at my desk and I'm composing an email. So I compose an email to some guy at some other installation or some other university. So I'm finished composing the email and hit send. And off in the distance I hear the modem go connect to that machine, send the thing, and then it dropped. So it's kind of sort of like always connected, but it's not. I mean, really, right? I mean, it's still circuit switching, right? I build a circuit by dialing and connect, but it's not like I make a conscious effort to connect the machines and then leave them connected. I just dial on demand, and when a packet needs to send, I just send the packet, and then presto, change out. Okay, so it's kind of sort of working. In this picture, there are no routers. So there's no routing going on. There's no routing whatsoever. There's no aggregation. In other words, I don't collect data from other people's machines and send them along the way. It's just me. And these were like 56 kbaud modems in here. So it wasn't all that particularly fast. Okay, so one more time, just to drill home the point. My machine had to have the phone number of the machine I was talking to. So if I want to talk to that guy, and I'm over here, this machine had to have the phone number of that machine. And this machine had to have the phone number of that machine. And so you maintained a list of phone numbers of machines. And there was no routing. So if I wanted to send something to someone else, I would send it to there. And then if it was an email and it wasn't destined for those guys, then they would fire up their modems and they would forward it on. But that was clearly up to the machine to do that, because There's no routing going on. I merely talk between the two machines. If something else has to take place, well, it's the other machine's responsibility for doing whatever the heck that other thing is. Okay. So that's how it started, dial-up. And then later they had what they call T carriers. And T carriers are these things where, here's how it really worked, okay, in real life. So phone companies, plural, multiple phone companies got out there and went, you know, we could probably make some money off of this. You know, all this dial-up stuff. What if we had a dial-up connection that was not on demand, but just stayed connected at all times? We'll still be using the phone technologies, except we're not going to be doing circuit kind of building. We're just going to have an always-on packet kind of thing. So they figured out they can make some money off of this. So they decided that, okay, I'm going to connect all these branches together using like a T1. You've probably heard of a T1 line. So phone companies saw a way to make money off of data. Up to this point, you know, they were voice companies. They made their money with long distance charges, and they didn't have anything to do with data. It was sort of like, yeah, okay, whatever, dude. In the book, they talk about, in the days when they talk about T1, they also called it digital signals or digital service, DS. And so there's actually a DS classification of DS0 and DS1, all these kinds of things. So now a T1 line and DS, those terms are kind of synonymous, and we don't really make a distinction anymore. But the bottom line was, in their mind, they were voice companies that were just dabbling with data. Okay, at that time. So there's a little diagram here that says basically how they did it. They took 24 line till now. Okay, in the old days, when you asked for a T1 line, you got a big fat cable that actually had 24 phone pairs in it. Okay, 24 phone pairs cable. Cable's about an inch thick that they ran to your place, and they spit out those 24 pairs of lines and hooked them up to this thing. So this is a T1 line is 24 of these phone lines, which if you were using the DS designation, that'd be a DS1. So 1.5 megabits per second is what a T1 line would do using phone lines. Now, a single phone line could do 64K, and you're thinking, no, wait a minute. In dial-up, I can only get 56K. So how in the world can I get 64K out of essentially using the same lines? Well, the 56K has to do with not just the available bandwidth, because that part is roughly the same between the 64K and the 56K line. In other words, the available bandwidth is about the same. It's that signal and noise ratio kind of thing, and how much error rate I'm actually going to get. That's where it is. Things got a little better, and if I didn't have to do voice coupling between the two devices, I could cut that part out, and I could actually get a tiny bit more speed. Admittedly, it's not much. The difference between 56K and 64K, it's not that great, but hey, it is enough. Okay, so back in the day, you could kind of sort of get a poor man's T1 line. It was called ISDN. I had an ISDN service at my house, and I got 2 of those 64K lines coming in, and I could bond them together and get a 128K connection, which is pretty doggone cool. And it ran through both of those connections. This is where it's going to sound a little weird, so just bear with me. 2 64K lines went through the same copper wire that's run to my house before. In other words, they didn't run any more additional wires to my house. They just took the exact same wires and bolted these 2 things on there. And we'll explain how they did that in video coming up really, really quick. Okay, actually, this is probably a good place to stop for the 15-minute mark, and we'll pick this thing up again in just a few.